It is the top of the hour. It's 9 p.m. Eastern Time. Welcome to the Global Math Department, everyone. My name is Lee Natero, and I will be your host tonight. Tonight, we're going to be hearing from Sarah Powell about what works in math intervention. Would everyone please introduce themselves in the chat window, telling us what you teach, where you teach, and what your Twitter handle is, if you have one. I'm glad to see some familiar faces here tonight. Welcome from Iowa. I used to actually live in Iowa, Lynn, in Ames, Iowa, when I started my teaching career. I saw somebody here from Denver. That's Mindy. Welcome. I'm so glad to see everyone here tonight. Before I introduce our speaker, let me explain how these meetings work. These meetings are recorded and are available within 24 hours after the meeting ends. To view the recording, you could use the same URL you used to get here tonight. The Global Math community prides itself on being friendly and supportive. The chat room is available for topical and general conversation throughout the meeting. I'll catch your questions for the presenter, so don't worry that the presenter won't notice your questions in the chatter. Tonight, our speaker is Sarah Powell. Sarah is an associate professor in the Department of Special Education at the University of Texas at Austin. Powell is currently the principal investigator of an Institute of Education Sciences efficacy grant related to word problems and equation solving for third grade students experiencing mathematics difficulties. Powell is also either the principal investigator or a co-PI on many other grants, including ones involving multi-step word problem solving at the fourth grade level, developing a science intervention for second grade students with learning difficulties, middle school algebra readiness, a grant about kindergarten computational thinking through music. In 2019, Sarah was awarded the Presidential Early Career Award for Scientists and Engineers. Her research interests include developing and testing interventions for students with mathematics difficulties, with a special emphasis on peer tutoring, word problem solving, mathematics writing, and the symbols and vocabulary within mathematics. And now I will turn the microphone over to Sarah.
All right. Thank you so much, Lee. Hi, everyone. It's so nice to see all of you. As Lee said, my name is Sarah Powell, and tonight we're going to be talking about what works in math intervention. I do work at the University of Texas at Austin, and this is some of my contact information. So I have put this entire presentation on my website. So if you visit sarahpowellphd.com and you click on presentations, you will see a little button right there that you can download the whole presentation if you'd like to review it or share it with colleagues. And please feel free to email me or find me on Twitter. I'm finding some of you so that we can find some math chat on in the Twitterverse. So I'm really excited to be here tonight talking about what works in math intervention. And I wanted to kick off by asking about you. Lee has already done that. So if you haven't already, introduce yourself in the chat box. Say hi, tell me what grade levels you support and what math you teach. And we're going to use the chat box quite a bit tonight. So please make sure that you've always got that handy as we go through this webinar. So tonight's webinar is focused on math intervention. And I'm going to be focusing on math intervention for students that experience difficulty in mathematics. And these students may fall into two categories. They may be students that have a school identified specific learning disability and IEP goals in mathematics. But more often than not, these are students that don't have a school identified disability, but they're showing persistent math difficulty. So most often these students receive all of their math instruction in the general education classroom and then may require some targeted or supplemental support. So here on the right-hand side, you see some common names for that support. So they might be receiving tier 2 or tier 3 intervention, secondary intervention, something that's called targeted or intensive or supplemental intervention. And some of these students may be involved in special education. I'm just going to call this math intervention tonight. And everything that we're going to talk about are things that are important to think about as we provide math instruction to those students that experience math difficulty. And we're going to let our conversation tonight be guided by evidence based practices. So, this is the IES, or the Institute of Education Sciences Practice Guide. And this guide puts together the set of evidence based practices that are important to use when students experience difficulty with math. And there are 5 practices on this guide that show moderate to strong evidence. One is about screening students to then provide math intervention to those who need it. And the other 4 talk about using explicit instruction, providing intervention in word problems that's related to structures or schemas, helping students see mathematics through a variety of visual representations, and helping students build fluency. And so, those are going to be the evidence based practices that guide our conversation tonight as we both design and think about the delivery of math intervention. So I'm going to move pretty quickly tonight. If you do have questions, please put them in the chat box. I'll try to answer them as we go. I'm also really going to try to leave about 10 minutes at the end so we can engage in math conversation about math intervention. So, we're going to talk about the design of math intervention and the delivery of math intervention. And the design of the math intervention occurs before we ever start teaching students math. And there's 3 really important things that we want to focus on: figuring out what's the critical content that we need to teach, what are the evidence based practices that we are going to use to teach that critical content, and then how do we create what we call the instructional platform. So let's first talk about that critical content. Often I want to think about math as developing along a continuum. So at the bottom, I have a line that's kind of my continuum of mathematics. And at any point, whether you are Trista, who's supporting students in K through 5, or I see Nick here, who's supporting students in 9th grade, at any point, you have students on a continuum of math learning. And you have students where we want students to be where the green arrow is on our line. But you're here tonight probably because many times we have a few students that are where the red arrow is. And that area between the red arrow and the green arrow, that's where math intervention comes into play. As we try to fill some of those foundational gaps for students in terms of their mathematics learning, that's what we're going to do in math intervention. So as we think, oh, we've got this group of students or maybe a single student that require math intervention, we have to think about, well, what's the critical content that I need to teach to the student? So maybe the student needs help in place value. So we could look at the critical content as it develops along the mathematics continuum related to place value. So here, if I look at this orange standard, that's where I want my student to be, but their performance is around the lime green standard. And so that math intervention is going to come into play to help us teach that critical content. So here, most likely the green, the purple, and the orange, to help this student fill in some of those gaps that they have in their mathematics learning. Now, that's an example from place value. And often we aren't just teaching students one example or one, I would say, content area in math in our math intervention. Often it looks a little bit more like this. So if we want to focus on problem solving, and I will tell you that this slide is usually animated, so it looks a little bit messy. I might want to be teaching students about solving multi-digit word problems. But in order to do that, I have to bring in standards related to fluency and understanding the operations. In order to do that, I have to think about how students understand place value and how they interpret that place value within multi-digit problems. And so this ends up being more what a math intervention critical content timeline looks like. It's a little bit messy. There's lots of different content in here, but we think, okay, we're starting here around this red arrow and we want to move to the green. So it's that space between those 2 arrows that's going to drive the content that we are going to focus on in our math intervention. And when I say critical content, notice I say critical. I don't just say content, because here we often have to make choices. We cannot teach all 25 or 35 mathematics standards from a single grade level. We don't have time to do this. Many students that require math intervention are already performing several grades lower than we would expect them to perform. And so we have to focus on what's critical. And some things that I use to determine that critical content, I love this picture from Achieve the Core. Probably a lot of you have already accessed this already, but it shows what are the absolutely essential skills that students should master as they progress across grades K through 8 to being successful with algebra in high school. And I also love a lot of the resources from the National Council of Teachers of Mathematics. So here are the curriculum focal points, and it really says, hey, these are the 3 or 4 things that we really should be focusing on in this grade level. And so, as a person that designs intervention, this is one of the resources that I use to figure out, well, what's on that critical content timeline that's going to drive what I do in my math intervention. So, in the chat box, if you live in a state that has a letter A in the name of your state, I'd like you to put in other resources that you use to determine critical math content. So, if you would like to put in any of those, then that would be great so we could see those. And I'll pause for just about 15 seconds or so before we move on to our next slide. And I will say, if you absolutely really want to share another resource about critical content and you don't live in a state that has an A in the name, it's okay to share as well. I won't be checking up on you. So Julie says she likes the California state framework. I agree with you, Julie. You must maybe live in California. I live in Texas, so I'm very well versed in the Texas standards and use a lot of Texas resources. But even though I live in Texas, I also like to understand what are the national expectations for students in math. And Lynn, you talk about my favorite textbook in the world by John Vanderwall and colleagues. They've got some really good resources related to those big buckets of math as well. All right, so we just focused on, oh, it looks like Zeth is talking about Agile Mind and Trista is talking about the readiness teaks. Hi, Trista. So we just talked about determining the critical content for our math intervention. And next I want to talk about, well, now we know what content we need to teach. So now let's figure out what evidence-based practices we should use to teach that content. So, when I think about this term evidence based practice, that's an umbrella term. It can mean several things. It can mean an evidence based intervention. So, this is a packaged intervention. Maybe it's paper and pencil based, maybe it's virtually based, but you buy this whole intervention and you can implement the whole thing to teach that critical content. But often, there aren't always evidence based interventions available at your grade level or for the mathematics content that you want to focus on. So then sometimes we have to rely on evidence based strategies. This is not a clean packaged program, but it's a method, a teaching method, or a strategy that really has shown time and time again to show consistent and positive results. So evidence based strategies are using explicit instruction or using multiple representations like virtual manipulatives or physical manipulatives to help students understand math concepts. And you can also rely on promising practices, things that are starting to develop an evidence base, but maybe that evidence base hasn't grown really strong at this point. But that's still better to rely on than those things that don't have evidence or actually show negative evidence. And there are a few math interventions out there that have shown that they do not improve the mathematics outcomes for students that experience difficulty with math. And so we would definitely not want to waste students' time by using those programs. So when I think about, well, where do I find these evidence-based programs? They're usually scattered about. So I will rely on the What Works Clearinghouse. I will look at the Evidence for ESSA website. Also, I look at edreports.org. And if I'm really focused a little bit more in the realm of special education or math intervention, I'll visit the teachingld.org website. This comes from the Division for Learning Disabilities from the Council for Exceptional Children. The Evidence Based Intervention Network. This comes from the University of Missouri. And probably my favorite go to is the National Center for Intensive Intervention, or many people call this the NCII. They have a ton of resources related to what are evidence based practices to use in mathematics, what are good evidence based assessments to use in mathematics, and they have a lot of other stuff in reading and behavior. I'm not going to talk about that tonight, but at the end, I will share a resource or several resources from the NCII that are really helpful to use within your math intervention. And Erica asks, how do we find the interventions that are not good to use? So, a lot of times you have to dig deep on this. I had someone from the state of Pennsylvania email me last week and say, hey, what do you know about this program? And so I spent about 30 minutes trying to find the research that supported that program. And once I found it, it was a really small number of classrooms and it was only what they call like a pre post test design. So they never compared it to a control group. So I was a little bit wary about recommending that program. If you need help with that, especially if you're really interested in, hey, what do you know about this program? Feel free to email me, and I'll try to be on your side and help you find some of that evidence if it exists, which it doesn't always do that. So, in terms of design, if you are in the chat box and you like tomatoes, what would you say are some of the other resources that you can use to locate evidence-based practices? So, there's lots of resources out there, but which ones do you use? I'll pause a few seconds while people start that conversation, and then we'll move on to thinking about our instructional platform. I will say, David, it's hard to figure out. David says he was wondering how to find the interventions that are not good to use. Nobody likes to publicly shame programs or interventions or strategies. And so it's really hard to find a list that doesn't have evidence. For a while, I think it was the Best Evidence Encyclopedia from John Hopkins would say if they evaluated a program and it didn't have evidence, and I think Ed Reports does that as well. So you can find a little bit of that information out there, but often it takes either reading something that they have produced, like a brief, or looking pretty deep on the website. And I will say, if an intervention doesn't have evidence, and that you can't find it, it's probably not that great. Many times, if it does have evidence, it's going to tell you, on the first page of a website, hey, this helps kids, and here's how we know this. So when you can't find that evidence, that's when a little bit of a red flag pops up for me, and I'm a little bit suspicious. All right, so in terms of thinking about this design of our math intervention, we focus on critical content, we identify the evidence based practices, and then we need to create the instructional platform. So, the instructional platform is our jumping off point for providing the math intervention. And again, I'm going to put into my instructional platform evidence based practices that time and time again have shown useful and helpful for students that experience math difficulty. So, in the instructional platform, these are the 5 things that we typically start with. I'll say start because there you might want to add some extra things to this. But in terms of delivery, we know that one of the best ways to deliver and involve students in instruction is by using explicit instruction. And I'm going to break down each of these on some subsequent slides. So this is just an overview. So we want to make sure we're using explicit instruction, and that should be paired with precise mathematical language. And then also, as we deliver our instruction, we want to make sure that we're bringing in multiple representations so that students are seeing and practicing math in a multiple variety of ways. And then, 2 other things that are really important to use in the instructional platform. The first is fluency building. Probably all of you will shake your head and agree with me when I say that most students that experience mathematics difficulty really show that they don't know all of their math facts, that they struggle with computation of whole numbers and rational numbers. And so that's really one of the building blocks of math. So we need to embed fluency building activities into every math intervention session that we provide in order to help those students fill in that foundational gap so that when they get to more complex mathematics problems, it's going to be easier for them. And then we also want to think about problem solving instruction. In every state in the United States, when students take a mathematics exam, it is a problem solving exam. And so if we aren't practicing how to teach students to be efficient problem solvers and how to dissect word problems and approach those problems, then we're really doing a disservice to students. And so we need to make sure that all of our math intervention sessions also include a component related to problem solving instruction. So it's these five things that all have an evidence base that we're going to use as our jumping off point for starting to deliver our math intervention. That's why we call it the instructional platform. Platform's kind of where you jump off into something. And this platform is going to be adapted as we learn more about the students and as they move forward in their mathematics knowledge. But this is a good place to start. So I'd like to ask you, if you have a birthday here at the end of the year, either this month or November or December, are there other components that you might want to include in your instructional platform? I may beat some of you to the punch, but typically, we want to include a motivation component in our instructional platform just to get students to make sure that they're paying attention and making sure that they're confident and that they are self regulating themselves as they work in the math intervention. So, that's one component that I might usually add into my instructional platform. But are there others? Remember, this is not everything that we're ever going to do while we're teaching math, but it's a good jumping off point. All right. So either no one has a birthday in October, November, or December, or no one has extra components to add to the instructional platform. So far has a great question. I'm wondering where inquiry based instruction falls into this. Well, we're not going to talk about that tonight, Far, because in the world of special education and in the world of math intervention, there's really not a strong evidence base for using inquiry based instruction. There's a lot of research out there that supports the use of explicit and systematic instruction, and you can do some inquiry based learning within that. But overall, the overwhelming set of evidence is going to rely more on explicit instruction so that we can help these students develop a strong understanding of mathematics. So then hopefully that they can go on and participate really well in the general education math classroom. But it's just something that doesn't have a strong evidence base in 2020. Maybe in 2025 that might change. I'm always hopeful that research finds out more about that, but we won't talk about it tonight because I do want to rely on the things that we know are essential to use for students that experience difficulty in mathematics. And Nick, you bring up active participation, and we are going to get into that in just a minute. So, when we think about the design, I'd like you to think about determining that critical math content and identifying the evidence based practices that you can use to teach that math content, and then embedding those evidence based practices into the instructional platform. So now I want to switch to the delivery of the math intervention. And we start here with our instructional platform. And I'm going to talk about each of these five components in a little bit of detail. And I know, Nick, you talked about active participation, and we're going to see that play out here in what we call explicit instruction. So, when we think about explicit instruction, this is a combination of modeling and practice with essential supports that are going to be embedded within both modeling and practice. And when we think about modeling, we'll talk about that one first. Modeling involves a clear explanation that typically starts off with a goal. So, here's what we're working on today, and here's why this is important. I have some examples on this slide. I will not read all of them out loud, but our turtle tonight is our teacher, so teacher turtle, and you'll soon see our seal, which is our student seal. And so you'll see how some of this might play out between a teacher and a student. So modeling involves a statement of the goal. So here the teacher says we're working on division and this is important because, and then we follow that by a modeling of steps. So if we were going to solve this problem, 26 plus 79, our teacher might kick us off by introducing the problem and then talking about the operation and immediately asks the student a question. Well, what are we going to do here? Are we going to add, subtract, multiply, or divide. And then the teacher will say, that's right, that plus sign tells us to add. What is the sign that tells us to add? So we're just checking for understanding and getting feedback from our student seal. And then the teacher starts to say, okay, we're going to use a partial sum strategy to add 26 plus 79. So first I'm going to add the tens. Well, what is 20 plus 70? So even though the teacher is modeling, the teacher is kind of the driver right now of the explicit instruction, you can see that the student is actively involved and thinking about the math as the teacher is working through this problem. So our student seal would say, well, that equals 90. And then the teacher would confirm that, yeah, 20 plus 70 is 90. Let's go ahead and write 90 below this equal line. Where should we write it? So the student participates in the discussion here. And then the teacher would move on to adding the ones. And then we would figure out, well, where are we going to write the sum of 15? And now we have to add these partial sums. And then our student helps figure out the answer with the teacher. So it's a very, very brief and very easy example of modeling of the steps. I don't want to spend too much time on this, but you can see that when we model, it is a discussion between the teacher and the student. It's not just the teacher doing all of the talking. Now, as we model those steps, it's really important for our teacher turtle to think about, well, what examples am I going to bring in tonight? So, if I'm teaching division, how do I want to show that? Do I want to show different ways that division can be shown? Do I just want to focus on division with what we would think about the division symbol or the obelisk? Do I want to show the long division bracket? Do I want to show this with the slash? And we also, in our explicit instruction modeling, need to bring in non-examples. So here, if I am focused on division, I may want to present the student first and we will do 32 divided by 8, and then 42 divided by 7. And then I might want to present this problem 25 minus 5. If your students are a lot like a lot of the students that we work with here in Texas and elsewhere in the United States, a lot of students would answer that as 5 because they just are thinking like, oh, we're just dividing, and they're not really paying attention to the operator symbol. And in fact, research shows that the most common mistake that students make in mathematics in the elementary grades is they do the wrong operation. And so this is an opportunity in your explicit instruction to bring in these non-examples and ask, well, why wouldn't I divide with this problem? What about this problem tells you that it's not a division problem? And if it's not a division problem, how would you solve this problem? So then that's an opportunity for the teacher to toss it to the student and for the student to activate prior knowledge about solving this problem 25 minus 5 instead of what they might interpret as 25 divided by 5. Now, as we go with this delivery, I want you to think about this modeling. So, if you taught math yesterday or today in any way, shape, or form, I'd like you into the chat box to answer, well, why is modeling important for your students? Think about some of your students that might experience math difficulty and why might this modeling be important for those students? And again, if you didn't teach math yesterday and you really want to answer this question, please do feel free to answer it as well. So, when I think about modeling and thinking about the importance for students, it's really filling in a lot of holes in math knowledge. So Mindy's, I think, starting to get into this. It helps them gain conceptual understanding for a problem. And Alan says it helps them see the steps. That's right. A lot of times many students have some of the steps, but not all of the steps. And so this modeling is going to help them see, oh, that's how I do that entire problem. And let's see, Heather says it's helping with scaffolding. Lisa says it's helpful so it's clear to the students how they can see how this think aloud process. And Lisa, I'm glad you bring up that idea of thinking aloud because many times when I think about the explicit instruction that I provide to students, a lot of it is a think aloud, right? And it's with a discussion with the student. It's not just me sitting there being like, here's how to solve this problem, but it's actually like, hey, let's solve the problem together. And I'm going to talk aloud as I solve this. And David, I'm glad you bring in helping them see the pieces that they have to coordinate coordinate to do math, especially pieces that we may have forgotten about. Remember, you talked about fractions last week? Let's go ahead and bring that in here to solve this problem. So, when we have modeling, that really sets students up for success. But the real learning in mathematics occurs through practice. So, there's different types of practice that we need to engage students in. One of those is guided practice, where the teacher and the student would practice together. So, here our teacher Turtle says, "Hey, student Seal, let's work on a problem together." If we were in classrooms, a lot of times this might be the teacher working a problem on the document camera and the students working a problem in their workbook or on a whiteboard. If you're doing small group intervention, we often do this where we have a whiteboard and the three students around us have a worksheet or have their own whiteboard or have their own set of manipulatives. There's lots of ways that this can play out. In remote environments, I've been doing some teaching of my nephews who are in fourth grade. I've been their math teacher now for about 7 months. They live in Massachusetts, and I am always doing problems on the whiteboard function on Zoom, and they're doing the same problems alongside me. So, this is part of that scaffolding. And I know someone already mentioned that, but where they've seen the modeling, and now we're going to practice this together. I haven't released all the scaffolds yet. That occurs when we engage students in independent practice, where students practice, independently, but the teacher is there still to support. Now, the practice is where the learning of mathematics occurs. And for students that experience mathematics difficulty, they often receive fewer practice opportunities than other students in the classroom. And there's many reasons for this. One is that they may have trouble understanding all the different parts of mathematics. So maybe they work a little bit slower. Maybe they have mathematics anxiety and they get frustrated and they kind of time out and they write IDK on their papers. Also, a lot of times students that experience math difficulty, they have reading difficulty as well. And so maybe it's hard for the student to read all of these problems. They're just taking a little bit of a longer time reading these problems. And so then they end up solving fewer word problems. Also, many times when students experience math difficulty, they experience difficulty with working memory. So they have a harder time keeping mathematics information in their working memory so that then they can regurgitate that information and use it during the lesson. And so they just work a little bit less efficient. And if you're working less efficient, you're solving fewer problems. And in a classroom, you've probably seen this where one student will do 10 problems and the other student will do only 2 problems. But across the week, that really accrues. And if the learning of mathematics occurs through practice, often the best thing that we can do in math intervention is give students opportunities to practice. Now, while both that modeling and practice goes on, I want you to think about, I'm going to stop right there. I want to think about how can you engage students in your guided practice? So how do you do math alongside your students? Are you on a whiteboard and they're on a whiteboard? Are you on a document camera and they're on a piece of paper? What are some of the ways that you do this? And if you wear glasses, I'd like you to answer that question. So I will say often we do a lot of tutoring in small groups, either groups of 2 to 4, and a lot of times we're sitting around a round or a rectangular table, and we do a lot of stuff on whiteboards. We do a lot of stuff with shared manipulatives. Lee says have them work with a partner. That's a great way to do guided practice. Jam boards, Jane, I love those. I've been using those with my pre-service teachers, and it's been going really well. So another way to do guided practice. Just lots of distance learning. So Julie also says she's using the Jamboard so you can see progress. We've done some work in just shared Google Docs so that we can see people are doing the same problems in different ways. And so we can see that. Chromebooks, doing think alouds. So there's lots of different ways that we can think about doing this guided practice. Now, as we put our modeling and practice in play, there are supports that are absolutely essential. If you are not doing these supports, you're really not doing explicit instruction. And so these supports include the following. So, first is asking the right questions. This is a mix of low level and high level questions. Low level questions are good just to be quick checks for understanding. They're also good confidence builders. So maybe our teacher turtle asks, well, what's 7 times 9? And our student seal says 63. But we also want to ask high level questions. These are our why or how questions. So maybe our teacher turtle says, well, why do you use zero pairs? And our student would say, well, because I have a positive one and a negative one, and those are equal to zero. So I could use those to subtract or add if I was doing anything with integers. So we need to ask a lot of questions. And then you might say, well, how often do I need to do that? So we need to get students to respond frequently. And in order for students to respond frequently, we have to ask questions frequently. So when we design intervention, I do a lot of intervention design for pre K. I've got a lot of stuff in the elementary grades and some stuff in the middle school grades right now. When we design those interventions and we put together lesson guides, we say that we have to actively involve students at least every 30 to 60 seconds. So if a minute has gone by and you haven't asked a question or asked students to do something or asked students to turn and talk to a partner, then you're going to start losing the students' attention and less math learning is going to occur. But those frequent responses can be very varied. You could have students do like a class-wide response, thumbs up, thumbs down. You could ask for an individual to respond or a partner pair to respond or to turn and talk to a partner. They could write something down. They could put it on their Jamboard. They could show it with manipulatives. There are so many ways that we can get students to respond. We just have to make sure that we're doing it frequently. And then when we ask students to frequently respond, we need to make sure that we're providing feedback to those responses. So, affirmative feedback. So, if the, let's see, I think I skipped that one. Affirmative feedback. So, if students are doing something really well, let's talk about what they're doing well. So, maybe the teacher turtle says, I really like how you're using your attack strategy to attack that word problem. And also corrective feedback. So, when students make a mistake, we usually will say, hey, let's look at that again. Can you tell me how you added in the hundreds column? That might be an example that our teacher turtle could use. And then another support is that we need to be really planned and organized. So have everything ready to go. Is all of our technology working? Because we do not want to waste time. In a math intervention session, we usually get students for about 25 minutes. And I want to guarantee that these students are engaged in mathematics learning for 25 minutes. So if I'm not planned and I'm not organized, and if I have to go over here and find these base 10 blocks or go over here and find a whiteboard marker that actually works, I'm wasting time. And that's helping students not engage in mathematics practice as much as they need to be. I'm not going to be able to do as much modeling as I wanted to do. And so we really need to make sure that we're doing our best efforts to be planned and organized so that we can spend the maximum amount of time on mathematics instruction. So, if you like to swim, which of these supports do your students receive the least? So, would you say that they are asked the right questions the least? Would you say that they elicit frequent responses the least? Would you say that they receive affirmative feedback the least? Or would you say that they receive corrective feedback the least? So either no one likes to swim or you're still very busy typing. I would say that the support that many students, when I do observations of teachers or tutors that are doing intervention, a lot of times people are hesitant to ask those higher level questions. They don't want to overwhelm students, but a few of those peppered in every lesson are really important to help students really get into the deeper understanding of mathematics. Yeah, Trista agrees. Like questioning is our struggle, and I think corrective feedback. That's another thing. Sometimes we're hesitant, especially if students answer incorrectly. often. But it takes so much more time to unlearn something and then to relearn it than to be corrected at the time that that misconception or that error is made. And so really think about what that's going to look like when you're providing your math intervention. And David and Erica talk about getting students to respond more often. This takes a while. I will say we have a word problem intervention that we've been running the last few years. It runs about 18, 20 weeks in the school year. And the first week is really quiet, David and Erica. I will agree with you. And we start with a lot of those low level questions to build confidence. I'm not asking that how question or that why question on day one. But then, as students get more comfortable and they're like, okay, it's okay for me to answer, because a lot of these students have been in general ed settings where they're really overwhelmed. They don't always understand everything that's going on in the mathematics classroom. And so these students have started to shut down, and some of them have shut down. They more than started. They're on their way to really disliking mathematics. And so it's baby steps, right? Asking little questions and also giving them, I'm not just going to raise my, don't not just going to cold call on someone, or you don't have to raise your hand, but you might say, David, in a few minutes I'm going to ask you to tell us how you solved this problem, and give them practice in answering that type of question. And Nick is agreeing here. Yeah, students really have to feel safe and that it's okay to make a mistake. And as students participate in especially smaller group intervention, they'll often start to feel that safety that they may not always feel when they're in a classroom of 25 or 30 students. So, as we think about modeling and practice, I described it as this nice 50-50 relationship, but it's not often that. So, as you can see here on the bottom left hand side of this slide, when we're introducing something new, you're probably going to do a lot more modeling, a little bit of practice, but you're still going to ask the right questions and getting students to frequently respond. But if you're reviewing material, maybe you've been practicing this for a few days, you might do a little modeling and a lot more practice, but you're still asking the right questions, getting students to frequently respond, and providing that feedback. All right, so I'm going to move on to think about the second component that's really important in terms of the delivery of our math intervention, and that's thinking about precise math language. This is from a study that some colleagues and I did where we assessed the glossaries in math textbooks, removed all the duplicates, and came up with a word count of how many vocabulary terms at different grade levels are students really responsible for understanding. And in grades K1 to, that number varies anywhere from about 110 to around 140 different terms. In third grade, we see a big jump up. Probably most of you are like, yep, that makes sense, because we introduced multiplication, division, fractions. And so your typical third to fifth grader will be responsible for understanding anywhere from 300 to 400 mathematics terms. And then we see another jump up in the middle school grades. So typically there, students are expected to know or understand anywhere from 400 to over 500 different vocabulary grades. And I agree with you, David. Whew, those great grade 6 students. And I say terms because many times these are terms that have multiple words in them, like commutative property or number sentence, or sometimes in the earlier grades, make 10. So you have to understand make and 10 and understand that make 10 is a distinct thing. And so there's a lot of vocabulary out there, and students listen to vocabulary. So as they're talking to you or talking to their peers, watching a video, we ask students to speak the language of math. We ask them to do a lot of reading in the language of math, and many times we ask them to write. And all of those are tied together by this understanding of mathematics vocabulary. If you don't know what it means to measure something or measure an angle, what is an angle, or what is a protractor, what tool are you going to use, it's going to be really difficult to do those tasks. And so some colleagues and I've been working on this about how can we support students in terms of clearer math language. And we've written an elementary article and a middle school article. I'm happy to share both of those with you. If you just email me, I'll send them along. But we come up with a few examples where we often see that we could be better with our mathematical language. So hopefully a lot of you groan when you see this slide. But instead of saying the alligator eats the bigger number, we should be saying something like, well, that means it's less than or is greater than. Instead of talking about carry or borrow, which are really procedural terms, we should be talking about trading or exchanging or regrouping. Instead of talking about the top number and bottom number, we should be referring to those as the numerator and denominator. And instead of calling this a point, which it's real, you really want to do that, that's actually called the vertex on that three-dimensional figure. So, if you are tuning into this webinar, which should include all of you right now, can you tell me an example from your either your teaching or things that you've observed where instead of saying this, it would be better to say that? So, I'll kick us off with an example. So, instead of saying answer, we could say sum or difference or product or quotient. So, if you are tuning into this webinar, if you could provide an example of instead of saying this, we should say that, I will share a few with our group. Instead of saying times, say multiply. Yeah, instead of saying going up or down, say increase or decrease. I like those. Both of those are really good. Instead of saying add a zero, say a multiple by a power of 10. Nice, Amanda. I like that. Instead of saying improper fraction, just say fraction or fraction greater than one. I was talking with my pre-service teachers about that last week, Len. Let's just call them fractions instead of trying to label them all the time. Instead of saying the first number in a subtraction problem, Julie says, say the minuend and then the subtrahend. And yeah, instead of 3/4, say 3/4. So really emphasizing the the language of the fractions. So those are some really good examples. So when we're thinking about our math intervention, we just want to make sure we're using our formal math language and using our terms precisely. And then, in addition to our explicit instruction paired with precise language, we want to bring in this idea of multiple representations. So here we want to help students see and work with math in different ways. So we like to bring in the concrete pictorial abstract to students, and a lot of you would refer to this as the CRA. With the concrete, we bring in hands-on tools to help students touch and feel math. Probably used to do a lot of this. I know even in my own, I teach a math methods class to pre-service teachers, and I used to bring in all my manipulatives and they all would touch the same manipulatives. We're not doing that anymore. So, probably kind of reconfiguring how concrete manipulatives are used in classrooms. But lots of pictorial visuals that we can use. So, these are two-dimensional images that can be used to express different math concepts and procedures. Lots of great virtual manipulatives that would categorize as pictorial. So here's on this example, algebra tiles, Cuisenaire rods, and geoboards. For my math methods course, I did put together a bunch of different virtual manipulatives that they can use. So if you scan the QR code, it takes you to that page. There's also a lot of resources out there available. I think Toy Theater is really one of my favorites right now. I hope that some of you have already found that. But these are virtual manipulatives that students can move around on the screen either with their finger or their mouse to demonstrate different mathematics concepts or procedures. And then we are doing all of this so that we can focus on, well, what does the mathematics in the abstract mean? So when we think about representing mathematics with numerals that are put together to form numbers, and we have bring in these symbols, and I would also say the words of mathematics, we bring in all these different representations so that students can interpret this mathematics in the abstract. So if you're left-handed and participating tonight, I'd like you to put into the chat box, what is one of your favorite manipulatives? As you are typing, I will share one of mine. They're in one of these drawers around me here, but I love the angle legs. Then I think it's ang legs or angle legs. I don't exactly know how to say it. These are just little plastic sticks that you can stick together. We've been using them for fractions and for geometry and even for counting and addition and subtraction. There's some really great stuff that you can do those. I love a good digital geoboard. Those are always great. Love the Cuisenaire rods for fractions and for early counting and addition and subtraction. Jane talks about the Rec and Rec. Oh, those are in my office. I haven't seen those in about 7 months. Chad likes the linking cubes or the snap cubes or the unifix cubes. So I'm glad we've got some lefties here, and I'm glad they've got some favorite manipulatives. All right, so as we think about our delivery of our instruction, then as I stressed before, a lot of students that experience math difficulty need help building fluency. So this may be fact fluency, and then beyond that, you might want to be building computational efficiency, maybe efficiency listing multiples if students are starting to work on fractions, and then even fluency with adding and subtracting positive and negative integers, or doing the same thing with multiplication and division. The idea around fluency is that we want to provide brief fluency practice, but it has to occur every time you work with your students. So I'd say 1 to 2 minutes, but it has to occur during every math intervention session. So there's lots of different ways we can practice fluency. These are some kind of like older school ways that still have an evidence base. Flashcards are a good activity, especially with graphing and self-regulation. Lots of different games that we can play and different activities and lots of technology. So there's really no excuse not to practice fluency because there are so many resources available to do so. And how do I put this into a math intervention session? We do this as the first thing that we do with our students every time they come to math intervention. We have a 2 minute fluency warm up to start every session. And speaking of confidence, that's a confidence builder, right? Like, oh, you're going to math intervention and, they might be working on something hard, but let's start on something that's a little bit easier. And so that's a good way to get students to start to build their confidence. So now if you're right-handed, what's one of your ways to practice fact fluency? So do you have any games or technology? Do you like, reflex or extra math? Or what are some of the other ways that you practice fact fluency with your students? And I'm going to have you type those in there. Oh, Leanna, you like the angle legs too. Awesome. I'll have you type in your favorite ways to practice fact fluency, and I'm going to talk quickly about problem solving so we can leave a little bit of time for questions. So, as I emphasized at the beginning, every math intervention session also needs to focus on problem solving because that's really the real world application of mathematics. If we're teaching problem solving, there's two things that we don't want to do. That's why I have red X's on here. So, if you take a picture of this and share it on Twitter, people will say, Sarah did say not to do these things. The first on the left is an example of a keyword poster. There's really no evidence that supports teaching kids to identify keywords and tying those to an operation. That's really an ineffective word problem strategy. As the same is really practicing word problems by their operation. So here's an example of a quote subtraction worksheet. So if you read these problems carefully, you don't have to actually read the problems. You just have to subtract. And in the real world problem solving, you're never told, hey, this is a subtraction problem. You're going to subtract. Students have to figure out that that's what they're going to do on their own. And so thinking about these two ineffective strategies leads us to, well, what is important to do? So, the two evidence based strategies when it comes to word problem instruction is teach students to have an attack strategy and teach the word problem schemas. So, attack strategies are strategies like these. Here's an example of ride and ridges. Here's an example of solve. In the yellow, here is cubes. That's probably one of the more popular attack strategies used in schools. The cube strategy is a really strong one. If you are going to use it, I would ask you to turn it into R cubes. Read the problem first. That's the most important thing in terms of problem solving, and it's the thing that students do the least when it comes to word problem solving. And the attack strategy that we often rely on the most is UPS check. It's very general. We can use it in first grade, we can use it in eighth grade. So students understand a problem by reading it, they make a plan, they solve, and they go back and check their work. And then we combine that attack strategy with the focus on the word problem schemas. There are six that we see with regularity across grades K through 8. Total problems are where we have parts that put combine for total, and difference problems we have amounts that compare for difference. In change problems, we have one amount that increases or decreases. In equal group stories, we have groups with an equal number in each group. In comparison stories, we have a set multiplied a number of times. And in ratios or proportion stories, we are usually comparing quantities. If this is to that, then this is to that. So that was a very brief explanation of the word problem schemas. Usually we'd spend about 6 hours on that one slide, but we don't have time tonight. But I just want to lay that out there that we should focus on those schemas. But if you have a plant in your house, I have one here behind me. I'd like you to tell us what's your favorite word problem attack strategy. Do you use cubes? Do you use solve? Do you use UPS check? I've run into about 25 different word problem attack strategies in the last few years, so I know there's a lot out there. So if you could type those in the chat box, that would be great. So we put these 5 things together to form our instructional platform. So again, remember, this is our jumping off point for providing our mathematics intervention. If you want some more resources about math intervention, I would go ahead and suggest visiting the National Center for Intensive Intervention. They, and I say I've helped them put together what they call the Intensive Intervention in Mathematics course. It's 8 different modules, all with videos and all with presentations to follow along. From the start of I have a student that struggles with mathematics to how do I implement this instructional platform with fidelity. So really everything you need to know about implementing intensive intervention. They also have a wide variety of other resources, downloads that you can use in your math intervention. So you can either type in this long web address, or what I do is I use my favorite search engine and I type in NCII math course, and it's the first thing that comes up. Also, some colleagues and I have recently put together a book about teaching math in middle school. This has a lot of this word problem stuff that I was just talking about embedded within that. And then most of this is applicable at the elementary grades and also at high school, but we were asked to focus exclusively on middle school. So if you are interested in that, you can check that out as well. But I'll finish there, leave about 5 minutes for questions. But do feel free to email me if you want more resources or want to talk about those evidence based practices. Please find me on Twitter. I'd like to find you on Twitter too and tweet about different math things. And again, if you do want this presentation, I have placed it on my website under presentations. So you can go to the website and find that and download it and share it with all of your friends. So thank you to Lee and the Global Math Department for inviting me to do this presentation tonight. Really excited to be here. I've looked forward to this for several weeks now, and I will open it up to questions.
Thank you for presenting, Sarah. There really was not a lot of questions that I saw, but if you have a question for Sarah right now, please feel free to type it in the chat. I feel like there was a little bit of sharing with different resources as you were presenting, but I didn't feel a whole
Yeah,
lot of
so
questions.
yeah. And I see that Jane and Trista both talked about numberless word problems. Those are so great, especially when you're trying to help students understand like the different structures of those word problems. You really can't go wrong with the numberless word problems. And it also helps you focus on the vocabulary. What's happening in this story? Oh, you're getting more. Well, what happens if you get more, if you spend some money? So that's an absolutely awesome resource to use when it comes to problem solving. And David likes to use the 3 reads. I've seen quite a few teachers mention that one before, so that's a good attack strategy as well.
All right. Don't know if I
All right.
see any questions at this
No
point.
questions. All right. Let's say,
Oh, no, here's one from Mindy.
Mindy, what are you noticing with your pre-service teachers right now? Whew. Um, Well, how are they doing and do they believe in the critical need for precise language? Mine do, Mindy, because on class one, I've written articles on this and I don't always like them to read everything that I've written, but they do read those 2 articles about instead of that, say this, and we do a whole activity on it. And so our pre-service teachers, it's a steep learning curve, right? I'm getting them the semester before they student teach, so they've been in the pre-service teacher prep program for a while. But there's still a lot to learn. And even what we find is I strongly work with the supervisors of the student teachers. So next semester, when the supervisors are going to observe them, they'll come back to me and be like, Sarah, did you say it was okay to use the word carry? And I'll be like, no, I didn't. And so we try to communicate across our department about how we can make sure that they are applying in their student teaching what they've been learning in the classroom. And it's really hard this semester because a lot of them aren't in a classroom doing practicum hours as they usually would be in a regular semester. David asks, what was the point? Was the point of formal language? Sometimes people avoid formal language with their intervention students so it's not confuse them. David, this is a great point. What ends up happening of what we've realized in a lot of our observations, and this is especially true in like late elementary, middle school grades, is that then the students that who are experiencing math difficulty end up learning the most vocabulary in mathematics. So when we're trying to like limit the language that we provide to students by teaching something else, then we're actually giving them more to learn. And when students are receiving math intervention and general education math instruction, then it starts to get really confusing. And so in a lot of my work that I'll do with PLCs in schools is the special ed team and the math intervention team and the gen ed team will all meet together, and we'll have all this people that provide 7th grade math support say, okay, how are we going to talk about this? What word problem attack strategy are we going to use? And really trying to get people on the same page so that students aren't having to learn twice as many terms for the same number of math concepts. And another thing we really talk about is that continuum of math learning. So if you say this to a 2nd grade student, is that the same thing that's going to be said in 3rd grade? And so in many ways, if we just teach it right the first time, it's going to be easier for students along that continuum of math learning. And Julie says the resource for critical math content, the one that I use is from Achieve the Core. They have a great website. If you can't find it on the website, just email me, Julie. And they have of just a really beautiful one pager of the critical math content as it accrues across grade levels. So yeah. David, yes, we use one formal language. And sometimes we'll say, so for example, I saw this earlier. We teach students about change problems where you have an increase. Well, increase is a formal math term. Well, what does it mean to have an increase? Well, and we ask students, well, maybe it gets bigger, maybe it's getting greater, maybe it's getting taller. So we'll ask them to really like, well, what are some of the words that come to your mind when we say increase? And then what are some of the words that come to mind when you say decrease? So we're connecting that language for the students, but we will always ask, is this a problem where there is an increase or a decrease? We will always use that formal language and try to emphasize that. So I'll stop right there and turn it over to you, Lee.
Well, thank you very much, Sarah. I really appreciate you being here tonight.
Oh, thank you.
And not a problem. I definitely am going to take a look at some of the resources that you mentioned, and hopefully share them with some of my pre-service teachers.
Okay, that sounds
Um,
great.
let's see. Our next presentation is actually going to be on the 27th. It's promoting mathematical literacy, what our students need to know, why they struggle, and how we can help. And it's a K-12 session that is being presented by Mindy Adair, who was actually with us tonight in the chat. So look forward to that in about 2 weeks. Thank you for joining us tonight, everyone. Have a nice evening.